Hello everyone, welcome to the QGIS Expressions Masterclass. It's really nice to be here. My name is Ujjwal Gandhi. I'm the founder of Spatial Thoughts. We have Vigna with us. She'll be the TA for the class. I've been using QGIS for almost 20 years, and expressions by far is my favorite part about QGIS. Expressions are really powerful. They can do so many things, but for beginners and even experienced users, it can be sometimes hard to wrap their head around all the things that expressions can do and kind of get a kind of nuanced understanding of the power of expressions. So I've designed this class to help you learn the expressions from the ground up. So we'll start from the very basics, understand how expressions work, how to interpret them, how to write them, how to combine different functions, and then we'll go through different use cases and apply them to solve different problems. This is going to be a beginner-friendly class, so if you just started using QGIS and you want to kind of get a better understanding of using expressions, this is a great class for you. For also intermediate and advanced users, I'm sure you'll learn something new and also gain a finer understanding of what expressions can do. In this class, we'll learn about QGIS expressions from the very basics. So first, we'll have a few slides where we'll understand what expressions are and what they can do. And then we have 4 sections in the class where we'll take a problem and solve it in QGIS using expressions. We'll slowly build our skills. The first couple of sections are kind of basics and kind of get a feel of what expressions can do, and then it'll get a little more advanced. And the last one is fairly advanced, but it'll get a kind of full overview of the power of expressions. All of the stuff we're going to see is available as a step-by-step instructions on our OpenCourseWare page, along with the data package. So if you want to try this out on your own machine, please go to this link and you can download the data package. If you're watching this on the video, the link will be in the video description, so you can follow along. A bit about Spatial Thoughts. Spatial Thoughts is an open learning platform. We spend most of our time creating, curating, and helping people learn advanced geospatial technologies. All of the learning material that we produce, including this particular workshop, is completely open source. They are explicitly licensed for use. That means if you are an educator or a trainer yourself and you want to take our materials and use it for your own teaching, we explicitly allow that, and we love when people take our material and adapt that. Many people have taken this and translated and adapted this in their own languages. So if you're looking for good training material for your students, please feel free to use our material. We also teach online classes where people pay and attend live sessions similar to this, but they are more longer courses. We also are a QGIS certified training provider. So if you attend our paid QGIS classes, you will get a QGIS.org certification as well. A bit of my introduction. I come from a traditional GIS background. I'm a civil engineer by profession, so coding did not come to me naturally. I had to learn it the hard way, and that's where I realized that people need a better path to becoming programmers and working with GIS, and that's why I've designed all my materials keeping beginners in mind and helping non-coders become more efficient with advanced technologies. I spent most of my career at Google. In 2020, I left to teach full-time, and I've been teaching classes like this ever since. So what are QGIS expressions? Expressions can be thought of as a statement. You can think of it as a statement that consists of some values, some functions, some operators, and you combine them, you write something, and that statement can be interpreted. So QGIS has an expression engine which will take the statement, evaluate it, and say what should be the answer to the statement. So it will evaluate it in the context of the current layer, current project, and this will result in some output. And that is an expression. QGIS has its own expression language. If you've used SQL or SQL, this will seem very familiar to you because it's derived from SQL. So if you've done any kind of SQL queries, some of the operators and functions will look very similar, but QGIS's expression engine, it's its own thing. So there are kind of differences between SQL and what QGIS uses, and you'll have to kind of learn how QGIS does some of the expression stuff. The great thing about expression is they are everywhere. You cannot use any part of QGIS without running into expressions. So learning about them will really help you improve your workflows in all of it, whether you use it for analysis, for mapping, for data management, all of those will allow you to use expressions. You can use expressions for selecting features or extracting features. This is probably the first time most people encounter expressions in QGIS where you have a layer and you want to select some features and save it to a new layer. And that's why I say I want to select some features. How do I build my expressions? You can also use it to create new columns. So you can say I want to create a new field by taking some other field values and computing a new value. You can kind of work with attribute table and edit or update attributes. You can manipulate symbology in QGIS wherever you have any setting in your symbology. So transparency, width of a line, or size of a point, everything can be overridden with expressions. And that means they become very powerful, where you can say, instead of using a static value, I'll write an expression, and based on the result of the expression, the symbology will change. So this is really powerful to create some really advanced symbology. Geometry generator allow you to kind of on the fly generate new layers or new geometries. We'll learn about this in this class. You can also use it for analysis. So when you're doing geoprocessing, using processing tools, the processing tools also use expressions, so you can specify what happens and how you want to process your data. And many more. You can keep going on. If you take any part of QGIS, you'll encounter expressions there. The first tricky part about expression is the syntax is kind of different than other places. So if you've written code elsewhere, or if you've written SQL queries, QGIS has its own way of doing things. The main thing is quotation. So if you put any name, any text in a single quotation marks in an expression, that is interpreted as a text. So when you say name in single quotation mark, QGIS will say this is the text name. So a single quote is a text. If you put any text in double quote, QGIS will think that's the value of the attribute. It's going to look for a column called name in your vector layer and say, what is the value of the name column for the current feature? So remember the quotation marks when you're writing your expressions, single quote when you want to refer to a text or a value, double quotes where you want to refer to a field value. If you prefix any text with at, that is interpreted as a variable. Variables can change its value throughout the execution of your QGIS program. So when you are writing an expression, the variable will have a certain value in the context of the layer or the project that you're working on, and the value of the variable will be, the value of at name will be represented with the current value of the variable name. So at is the symbol you use to refer to a variable. And finally, the function. If you have a text with parentheses, that is referring to functions. QGIS comes with a whole bunch of functions. So if you have parentheses, this is referring to a function. So when you say name parentheses, that's going to call a function called name and return the result of that. Right? So main thing people get confused about is the quotations. Remember, double quotes is referring to a field and single quote is referring to the text. Long-time QGIS users may remember that there are certain expression values that start with dollar. So things like dollar geometry, dollar ID. If you use this, they'll still work, but these are kind of older ways of referring to the variables. A newer way is to use at symbol. So dollar geometry is the current geometry of the feature. In the newer QGIS versions, they are referred as at geometry. So start using the at symbols whenever you use this. The dollar symbol has been deprecated, but they'll continue to work for foreseeable future for backwards compatibility. Let's understand what an expression looks like. You may encounter an expression like this: length of at geometry greater than 100. What does this mean? Here, length is a function. Why? Because you have the parenthesis next to it. So here we're calling a function called length with a variable at geometry. So when this expression is evaluated, it'll take the geometry of the current feature and say, compute the length of the geometry. There's an operator. Greater than is an operator. So it'll say, whatever is the length of geometry, is it greater than this value, 100? And the QGIS expression engine will take this expression, run it, and say, I'll compute the length of geometry, check if it's greater than 100, and it'll output a result. And in this case, it'll be true or false. So this will either be true if the length is greater than 100, false if it's not. Right, so this is what kind of an expression looks like. It's a combination of functions, values, operators, and variables. Our first section is going to be on operators and conditionals. So let's start learning about expressions. We're going to start our hands-on section now, where we'll learn about different operators and conditionals and how to use expressions to solve a problem. A bit of theory before we dive into QGIS. Operators are used to evaluate the expression. So I'll compare two values and say, how do I kind of use those two values and come up with a result? Most of the operators are derived from SQL. So if you're familiar with SQL, you'll be able to understand how they work. There are arithmetic operators, plus, minus. So if you want to add two numbers, A plus B, and so on. There are comparison operators. So A equal to B, A less than B, A greater than B. This symbol is not equal to. So this is equal to, and this is not equal to in QGIS. There are logical operators. So if you say this condition and that condition, so you have and, or, there are is. So for example, if you want to check if a value is null or not, you can say this value is null or this value is not null, right? So these are the kind of different logical operators that you have. We'll use some of this and try to build an expression and solve some problems. So we're going to dive into QGIS now. Here's the class material. All of you should have links to this. If you want to follow along, what I want you to do is go and download the data package. You have the zip file here. Once you download the zip file, you'll get this zip file here. You can unzip it and you'll get a folder. This contains all the data that I'll be showing and all the projects that we have configured for using the exercises. This data package also has a solutions folder, which has got checkpoint projects. Our course is divided into 4 sections. At the end of every section, we'll have a challenge where you need to kind of use the skills you've learned and try to solve a problem. And I'll tell you when you reach that stage, you can open up one of these projects from the solutions folder and then try the challenge yourself. So if you're following along, you can watch me explain the workflow, and when we reach the challenge, you can open up your data package and open up the project I mentioned and then try out the challenge. And all of you will have a chance to solve this and see if you can figure it out. So we'll start with our first section. We have step-by-step instructions on this page. I'm going to do this in QGIS so you can watch and understand. And here I'm in QGIS. I'm using the QGIS LTR version. Currently, this is QGIS 3.40. Most of the stuff I'm showing you should work in all recent versions of QGIS. Here in the QGIS browser, I'm going to go through the data package that we have downloaded and unzipped. And I'm going to open this project called Power Plants. And this is going to load these 2 layers. We have this admin 1 layer. This data comes from Natural Earth. This is all the admin 1 boundaries of the world. So think of them as states or counties, states or provinces, depending on which country it is. And we have a layer of power plants. This data comes from WRI. This is the Global Power Plants database. This is an amazing data set. It's an open access database of all the power plants in the world. And you can see, if I open the attribute table, there are 34,000 features. And these are all individual power plants that have been mapped with lots and lots of attributes. And this is a great data set if you want to understand emissions and energy security, etc. So we're going to use this data. The question that we want to answer is, I want a list of all hydropower plants in every state of my country. So pick a country, and I want for every state. So for example, if I pick India, I can see there are so many power plants. There are all kinds of power plants. There are some solar, hydro, coal-fired power plants, and so on. What I want to do is I want to get a list of all the hydropower plants in each state. So given each state, I want a list of all the power plants. So we'll see how to kind of do this using expressions. And we'll also say what is the total capacity of the power plants in each state. And we'll try to do this whole analysis in the most efficient way possible and using expressions. The first thing we want to do is we want to learn how to select those power plants. You can see there are different types of power plants. If I want to only select hydropower plants or coal power plants, how do I select them? Here in QGIS, there is a selection toolbar. So this is the toolbar with all the yellow icons. The second button here is the drop down, and there is an option here to select features by expression. This allows you to write an expression. It should be evaluated for each feature, and wherever it evaluates to true, you'll get that feature selected. So let's see how to use that. I'm going to use this button. It's going to bring up this expression editor. This you'll see throughout the class. Every time we want to write an expression, you'll see this dialog. Here is a space where we write our expression. In the middle is where this is a whole list of operators and functions that QGIS comes with. And on the right is the documentation. So here we're going to look at this section, fields and values. This contains all the different fields that our data has. So we're writing the expression on this power plants layer. And you can see there's a field called primary fuel. So I'm going to pick that. And you can see as soon as I double click, it's going to enter the expression with double quotes. Remember, double quotes always refer to the value of the column. So that means for each feature, it's going to say double quotes primary fuel will be whatever is the value of the primary fuel attribute. And we want to say select all the coal power plants. So I'm going to use the equal to operator and say I want to find all the coal power plants. Now I can also select an attribute and click this button, all unique. This is going to go through the attribute table and say these are all the unique values of this particular column here. So here you can see there's a coal value here. So I'm going to pick that. And remember now when we enter coal, it is entered in single quotes because single quotes refer to text. So this expression will say, check the current value of the primary fuel column for each feature. Check it if it's coal. If it's equal to coal, they'll be true and select that. Right? So this is how we build an expression. For many of this thing, you will be able to pick this from the expression editor, double click on it, and it'll be entered into the expression editor here, or you can just type it manually. Either of them will work. Let's click it, this button, and say select features. As I select it, you can see it shows this update that 2330 features were selected. And now if I zoom out, you can see there are all the features were selected, which were the coal-fired power plants. And so we could use an expression to select certain features. Now the question might become, okay, it was okay to select just one kind of power plants. What if I want to select power plants of both solar and hydro? How do I specify that? So let's go back to the expression editor. I'm going to open up the fields and values, and now we're going to use this primary fuel. If I want to say, check this value and say, I want all features where the primary value is either solar or hydro or wind or any renewables. I want to select all power plants with renewable fuels. How do I specify multiple values? There is a in operator. So if I go to the documentation here, there is a operator section. We're going to use the in operator. And QGIS expression editor is really nice. You can pick up any operator or function, and you'll see the help right here. You don't have to go through the documentation. And the in operator allows you to specify a list of values, and if either of them matches the value, it's going to select that. So we can use a list of all the different fuel types which are renewables. So here I'm going to specify this and say, if my primary fuel is any of this, select that feature. And this allows us to select multiple values. Let me click this. And now it's going to go through the features and selected 24,929 features. And now if I go through the attribute table, you can see everything is selected except the non-renewable fuels. Right? So this is again a way to select features with multiple types of values in a single expression using the in operator. When you're working with expression, sometimes selection is fine, but let's say I want to extract all the features that are matching a certain expression and create a new layer from it. You can also use expressions within the processing tools. So let's say for the question we want to answer is I want a list of all the hydropower plants in each state of my country. So for that, I would want to create a new layer with just the hydropower plants. So let me open the processing toolbox. Here, there are tools. If you just search for extract, you'll see there are tools such as extract by attribute, extract by expression, etc. They will allow you to write an expression and create a new layer with features where the expression evaluated to be true. So let's just use this one. Here, we're going to run this on the power plants layer. Here's the expression. We're going to click the expression button. So to bring up the same expression editor that we are now familiar with. We're going to say we want to create a new layer with only the hydropower plants. So I'm going to write an expression. I'm going to pick the same primary fuel attribute. And we're going to say select all the features where the primary fuel is equal to hydro. By default, when you run the tool, it's going to create a new temporary layer, which will have the name like matching features. It'll be nice to save it to the file and have a proper name so we can track those files. So I'm going to save it to a file on my computer. You can save it anywhere on your computer. I'm going to save it inside the QGIS expressions folder. And we're going to name this file as hydropower plants. By default, QGIS will save all the data as a GeoPackage file. This is a great open source modern format that is quite widely compatible. So do use GeoPackages whenever you can. Shapefiles are an archaic format with a lot of limitations. So GeoPackage is a great format for data management. And I highly recommend using this for any kind of work, especially within QGIS. So we have configured our tool, and let's run this now. And as the tool finishes, you're going to get a new layer which has only the hydropower plants. I can open the attribute table. Either I can right click and select this, or there's a button to open attribute table. There's also a keyboard shortcut, F6. So if you learn this, it'll save you a few seconds of hunting around for the right button. F6 will open the attribute table, and you can see now we have selected all the hydropower plants. What I want to do is I want to take this column, the capacity megawatt. So each feature has this column called capacity, which is the how much megawatt capacity power plant has. I want to take this and classify my data into 3 categories. I want to classify the hydropower plants into small, medium, and large. So if I say if the capacity is less than 25 megawatts, it's a small power plant. If it's between 25 and 100 megawatts, it's a medium power plant. Anything with more than 100 is a large power plant. I want to classify this. Now this can become quite tricky for many people when you are kind of trying to use expressions. How do I specify those multiple conditions? So let's learn a bit about conditions, and then we'll come and see how we can solve this using the QGIS expression. I'm going to switch back to the presentation. So the next bit in the expression we need to learn is how to specify conditions. Many times when you're writing expression, you want to say, if the condition is this, do this, or do something else. Most people will be familiar with the if statement. Most programming languages have that. So expression engine also has an if operator where you can say, if this condition is true, do this. If it's false, do that. So you can write if condition, and the expression engine do different things depending on whether the expression evaluates to be true or false. When you have multiple if conditions, like what we want to do is, let's say if the capacity is less than 25, do that. If it's between this and this, do that, or do that. If you want to write multiple if conditions, you should use case. And this is something that beginners don't often discover on their own. Now, if you know this, it's going to really help you in many workflows. So a case statement allows you to specify multiple if-else conditions. There's another conditional called coalesce. This is kind of less often used, but super powerful. It'll come in handy and kind of solve very tricky problems. What the coalesce operator does is, given a list of values, it's going to pick the first non-null values. So if you say coalesce field A, field B, field C, it's going to check the value of the field A. If it's null, it's going to take the second value. If it's null, it's going to take the third value. You don't need to know which one is not null. So you say, I have multiple values. I don't know which one might be null. Pick the first non-null values. And the coalesce does that. And it has helped me in so many tricky problems. So do remember that it exists. And if you ever need to kind of have multiple values and pick the first non-null, coalesce is the one that we can do that. All right, let's go back to our problem and see if we can use these conditionals to classify our power plants into different categories. So here you want to take the values in the capacity megawatt column and classify this into small, medium, or large. I'm going to create a new column in this attribute table. So I'm going to use this tool called field calculator. This is the field calculator that comes in your processing toolbox that allow you to create a layer by adding a new attribute to it. We're going to take the hydropower plants as the input layer. I'm going to name the new attribute as classification, and will the field type be text. Here again, you'll see the familiar expression editor. This is the same expression editor that you've been using. Now here is we write an expression. So we need to say, use the capacity megawatt and say, depending on the value of this, we want to assign different values. Since we want to write multiple if conditions, I'm going to use the case operator. I'm going to open the documentation for it. it's a conditional. So I'm going to open it here. So here's the syntax. The syntax is case, and then you write when this is the condition, do that. When this is the condition, do that. Else, do that, right? And then at the end, you say end. So let's write our condition. We'll say case when capacity megawatt is less than 25, then you should put the value as small. This is the first condition. We just wrote our first condition. We can continue doing this and say if my capacity is greater than or equal to 25 and less than 100, then it's medium. We can specify the other condition when capacity is greater than 100, then large. And once we are done with writing all conditions, we can just say this is end. Right? So this is how you write a case condition, which will allow you to specify multiple conditions quite easily in a single expression. Remember, when you're writing this, make sure to use greater than or equal to or less than or equal to, so you don't miss the edge values. So if you just use greater than here, and if the capacity is 25, that will be unclassified. So make sure all the values are covered. Use the greater than or less than equal to whenever it makes sense. And finally, we'll just want to save this. So we're going to save it as hydropower plants classification. So I'm going to save it to a new file. And I'm going to run the tool. So this new layer will appear, F6, to open our attribute table. We expect a new column at the end. You can see there is a new column with different values, small, medium, and large, depending on what was the capacity of the power plant. Right, so again, case statement is super helpful when you want to evaluate multiple conditions on the layer and have different results based on these conditions. Right, so we learned about operators and conditionals in QGIS and kind of created this layer of hydropower plants and classified them into different categories. Let's do our first challenge. If you are following along with hands-on, if you have QGIS open on your computer, you want to try out stuff you just learned, here's a chance. You can, if you want to catch up to this point, you can go to the solutions folder in your data package. There is a power plants checkpoint 1 project. So if I open this up, this will bring you to this point. So this is everything that we've done so far. You should have this classification layer, which we just created, and which will have the classification column along with the power plants database. So if you go to a data package, in the solutions folder, you'll find this power plants checkpoint 1 project and open it up. You should be ready to do the challenge. If you have this folder open in a computer in some Explorer or Finder, you can go to that solutions folder and also drag and drop this QGZ file. So we are using the power plants checkpoint 1 QGZ, and you can do the challenge. So Vigna, can you explain the challenge?
Yeah, so for the challenge here, you see that we have these 2 layers and we want to create a new layer which contains large hydropower plants in your country. So you see we have these 2 columns. One is country. It has like 3-digit code for your country, which you have to select. And from classification, you will have to select the value large. So you have these 2 conditions, and you can combine both with AND operator and try to extract using the expression. So try this exercise.
Yeah, so what we want is, let's say I want all the large hydropower plants in India. You need to figure out what is the ISO code for that country. So India ISO code is IND. You can also just search to find a page on Wikipedia with all the ISO codes, or you can say what's the ISO code for Sweden, for example, and you'll find that. And you need to figure out an expression that will allow you to extract all the features which are large hydropower plants in your country and create a new layer from that. See if you can figure this out, how to do this using expressions. Let's move on to the next section. We'll learn about functions. Functions are an important part of the QGIS expression engine. We'll learn how functions work and learn some of the kind of advanced functions and solve our problem. To continue working on our problem, we need to now use functions. So let's learn how functions work in the QGIS expression engine. Functions are something that takes some inputs. So the function can take some inputs, process them, do something with them, and return some result. And you can specify different inputs, and the function will take them and return a different result based on the input. There are many functions that comes with the QGIS expression engine. I'm always amazed at what the range of functions that QGIS comes with. Whenever I'm trying to do something, I'll search and I'll find a function that's been built in. You can do things like fuzzy text matching. You can interpolate points on lines. You can do wedge buffers using expression. So there are so many different functions that are available here, and they keep adding new functions to it. So next time you are trying to do something, search for the function, and you'll be surprised to find that it may exist in the expression engine itself. When you find a function and you want to use it, you will see a documentation like this. So here is a function called round, a simple function that say, give me a number, I'll round it to certain decimals. When you see a documentation like this, I want to show you how to interpret and read this documentation. First, the blue one is the function name. So this is how to call the function. So if you want to use the function, you type round, open brackets, and then here are the parameters. So the red ones are the parameters. There are certain parameters which are mandatory. You have to give the value for the function to work. So here is what's the value that you want to round it to? And we'll give some decimal number. The second value is also a parameter, but you can see it's within this kind of square brackets here. And it's also kind of specified in a different way. So this one is an optional parameter. That means you can skip it. If you don't give it, it's going to take the value, default value, which is 0. So if you just say round some number, if you do not give how many places you want to round it to, you will just round it to 0 decimals. Right? So many functions may have like 10 parameters, but only 1 or 2 may be mandatory. Others will just use the default value if you skip them. So if you call the round function with the value 3.14159, so value of pi, if you say round it, if you do not give any other parameter, you'll just round it to the nearest integer. It works like this. If you give the round function, you can also call it with a specific number of places that you want to round it to. So remember, the second parameter is the places parameter, how many places you want to round it to. So if you say round this number to 2 decimals, you'll get 3.14. You can write functions parameters like this. There's an alternate syntax which makes your functions much more readable. So you can write the same function like this, where you can say round, the first parameter is the value, which is value colon equal to, and the value, and the second parameter is the places. So you can say places colon equal to 2. Now this and this are exactly the same function, but this one is so much more readable. When you're reading this function, you know exactly what each parameter is. This one you may understand, you may have to refer to the documentation. So I highly recommend writing functions like this. It'll help you in the future to maintain those functions. Also, if somebody else is trying to understand what you did, writing a function like this is super helpful. The power of expressions comes from the fact that your functions can be nested. You can call functions on the output of other functions, and it can happen all in a single expression. So here's an example. Let's say we have this round function. So we say round, value is this, place is 2. You'll get 3.14. Now, there's another function in the expression called toInt, which will turn a number into integer. So let's say I want to take the result of this and turn this into an integer. Rather than doing this first and then the next step calling the toInt function, I can just do all of it together. So I can say toInt round of this. So first, this expression will be evaluated. It'll get answer 3.14. And then the toInt function will be called on the result, and my answer will be 3. So instead of doing this first and calling another function, I can just call 2 functions in once. And I can keep going. I can call like another function on top of this, and I can build this large expression. So many times you'll encounter some expressions which calls 4, 5, 6 different functions and result in something really complex and powerful. So again, this is something that once you get used to it, you'll know how to read those functions, how to write those functions, and things that might take you 100 lines of code or maybe 10 steps might be achievable just by writing a single expressions. We're going to use specific functions called overlay functions in the class today. Expression engine has a bunch of overlay functions which allow you to do spatial overlays. So if you want to do spatial joins, but you want to do this within expression, these are the functions that allow you to do this. There are functions named overlay intersect, overlay within, overlay touches, overlay nearest. These functions allow you to take 2 layers and then do a spatial join with them in real time using expression. These are super powerful, unlocks a bunch of new use cases. So we're going to use these overlay functions to solve our problem in course. Here's an example of how these overlay functions work. Let's say we have 2 layers. There's a layer called states and there's a layer called cities. This is a polygon layer with all the states. You have a point layer with all the cities, and these are the attribute table. I want to now know the list of cities in each state. So I want to take each of this polygon, intersect it with this layer, and say which points intersect with each polygon, and then get a list of their names. So what I want to do is I want to add a new column here in the states layer and saying in Texas, these are the cities that are within Texas. Now this is a problem that is very hard to do using any of the tools or any of the kind of traditional GIS techniques, but you can write an expression that can kind of do this join and extract the city name column from the intersecting features. So you can write an expression like this. You can say for a state, let's add a new column here with the expression overlay intersect it with the cities layer. So you can see the second layer is the name cities. So we're going to intersect this with the cities layer, and we're going to say, give me the value of the city name column. So it's going to take this each feature that the expression is being evaluated. It's going to intersect with the city layers, find all the intersecting cities, and it's going to give you the value of the city name column. So if I intersect it with this, it's going to say, I found these 2 points that intersect for this particular state, and the name of the value of the city name is Houston and Dallas and so on. So when I run this for the first feature, this expression will result in the list of all the intersecting cities that were extracted from another layer. And this will keep running. So when I run the expression, it's going to get evaluated for each feature of the state layer, and it's going to do this, and I'll end up with this new column with the list of cities that were intersecting for each of those polygons. Right? And this, we could do this in a single expression, which is a kind of complex spatial join and extraction of all the values of the city name, and we could just do this in a single step. So this is really powerful. We're going to use multiple of these overlay functions in the class, and we'll kind of get a more understanding of how they work. Okay, we're going to dive back in and continue working on our problem. So here we are starting with the section 2. Remember the problem that we set out to do? We wanted to get a list of all hydropower plant stations in each state in our country. So we have a layer which are the hydropower plants, but now what we want to do is we want to pick a country, and for each state of that country, we want to get a list of all the power plants. We're going to pick a country for the class today. I'm going to pick Sweden. This is the latest country I've been to, so it's on top of my mind. So I'm going to use that as an example. So we're going to take this layer and select a subset for the analysis. One way to do this is to apply a filter. So I'm going to right-click this layer and click Filter. And I'm going to say Country. And you can see these are the kind of 3-digit ISO codes that represent each country. I'm going to use the country code for Sweden. So it's going to apply a filter and select all features where country is equal to Sweden. And you can now see I've selected the power plants that have the value of the country column as Sweden. We'll do the same with the admin power plant admin column. In the admin layer, the 3-digit country code is stored in the column ADM0A3, and I'm going to use the same 3-digit code. And now I've selected and filtered the layer to have only used the states for Sweden. Let me just open up the attribute table. You can see now in my admin1 layer, I have 21 polygons. These are the admin1 units in Sweden, and these are the names of those admin1 units and a bunch of power plants. So if I open the attribute table of this, there are 142 power plants. What I want to do is I want to generate an Excel file where I have the name of the state along with the list of all the power plants in that state. This is not straightforward to do in using the tools or any other analysis, but with the expression, we have much more control of how we can use this overlay functions and extract data out of that. So let's see if we can do this with expressions. We're going to select the admin1 layer here, and we're going to add a new field to it. So I want to add a new column to it where I want a list of all the hydropower plants there. So I'm going to take this admin1 layer and use the field calculator. I'm going to open up the field calculator and open up the tool. We're going to name the field as power plant list. The resulting field type, you're going to use text. If you're just doing the analysis within QGIS, you can use the string list. So if you just want to store a list, QGIS can natively store a list of things, but most formats do not have a kind of way to store a list of things. So we'll just convert the list into a text. GeoPackages does have a way to store list of things as JSON objects, but again, they might cause some compatibility issues. So I'm going to just convert and store everything as text here. we're going to write our expression. I'm going to just open up the documentation for overlay intersects. So this is the function. You can see this has got many, many parameters. Only the layer parameter is required. All of them are optional. And again, you can see what are the default values if we keep specifying those. I'm going to type the expression. So we're going to intersect this admin layer. So admin 1 is the polygon layer. We're going to intersect it with the power plants layer. And so this one is the name of the layer that we want to intersect it with. So each feature will be intersected with the hydro power plants classification. It's going to find all the features or the points that intersect. What do we want to extract out of that? So we can specify the next parameter, and we say, I just want to get the names of the power plants. And as I write my expression, in the preview at the bottom, it's going to show the output of the expression. So you can see if I see this feature, for this feature when the expression runs, it gives you this list of names of all the power plants which are inside that particular state. Right? So just with this expression, we were able to create this list. We can, if you just want to store this in QGIS, we can store this as a list, but we want to convert it to a string that we can store as a column. So there is a nice function called array2string. This function will take a list of values and convert it to a string separated by commas by default, but you can specify any other separator. So I'm going to just say array2string. And as we said, we can nest our expression. So I don't have to do this in two steps. I can just do all of this in a single step. So the way to read this expression is first we're going to do the overlay. Once we have the overlay, we're going to turn the result into a string. Right? So this is how you can read the expression. You can see the result will be this string containing the list of all the power plants. And we're going to save to the results. We're going to just store admin1 power plant list. We can save this as a geo package, run this, and in just a few seconds, we now have extracted the list of all the power plants within each of those states. This is something that we were able to do with a single expression. The overlay functions are really powerful. We can also do a lot of interesting analysis and aggregation with it. What I want to show the next thing is, along with the list of values, it'll be nice to get the total capacity of the power plants. So you can see we have the attribute of the power plants where we have the capacity of each power plant. So what we also want to do is, along with for each state, we want to know the total installed capacity for the hydro power plants. So we'll say we have a list of power plants, but what's the total capacity? We want a new column for that as well. So let's see if we can compute that. So I'm going to take the last layer that we created, which is the admin1 power plant list. I'm going to add one more column to it. Let's do the field calculator, and we'll have the name as total hydro capacity. This will be just a number, the total capacity, so we can store this as a decimal value, and we can write our expression. The expression will be very similar to before, so we can just do overlay intersects. We're going to find for each polygon of this admin1 layer, we'll say take the power plant layer, hydro power plant classification, and now when we find all the intersecting points, this time I don't want to have the name extracted, I just want the capacity. So I'll say extract the capacity value. So now if you see, you'll get a list of numbers, which is for each point that was within that polygon, we have a list of their capacities. And this is what this expression does. So now we have a list of capacities. I just want the total. How do I total all the values in an array? Well, I look under the array section of the function, and we'll call looking, and maybe we'll find a function. So there is a function called array sum, which is give me an array of values and I'll sum up the result. So that sounds like the right function to use. So I'm going to call this function on the result. I'm going to call this, and now you can see we have a single number, which is the total capacity of all the intersecting hydropower plants for each polygon, and we have computed the total. Let's just save this layer out. We can save this as admin1 power plant capacity. And now if we see the resulting attribute table, now we have for each admin polygon here, we have the list of power plants and a total hydro capacity. an analysis that might have taken you a long time to figure out how to do this, but once you kind of build your intuition around expression, you can just write an expression and do this very fast. We are done with this analysis, but I want to share one more tip with you. Whenever you do your analysis and you end up with this messy looking attribute table, typically I don't like having my results saved with a lot of unwanted columns, and I also want my column names to be organized nicely. So when I finish an analysis and I want to save the results, I typically run this tool from the toolbox that is called refactor fields. This may as well become your favorite tool from now on. I always do this at the end of my analysis. I run refactor fields to organize my output attribute table. So we'll take this, open up the tool, I'll show you how this works. So this is a layer that we want to save, and maybe somebody asked, hey, can you generate a list of all the power plants with the capacity for this country? And you say, here, I want to send something to them. So you did the analysis. After that, do they really need all these attributes? Maybe not. All they need is the name of the admin unit and the list of power plants and the total capacity. So all these columns are unwanted. So I can just select all the columns which I don't need. So I can select on the row number here, hold the shift key and select this once. There's a delete button, so I can delete those columns. Also, I can go and delete the columns I don't need. So all of these columns are something that I don't need in my output. So I can just go and delete those. I can also reorder. So if you want to rearrange the order of the column, I can do that. If you want to change the name of them, I can do that, change the data type. So all the configuration, you can do it here. And finally, you can say, I just want to save this result with this nice formatted attribute table. And I want to save this out. So I'm going to save this to a file. Now you can go and save this as a geo package, but for many analysis, the results can be best shared as just a table. Here, somebody asked you to create a table of all the power plants in each state with the capacity. You may as well send them a table. You can just say, I will share you an Excel file. You'll be surprised to know that QGIS can read and write Excel files quite easily. So I don't want to save this as a geo package. I want to save this as an Excel file. So I'm going to save my output as an XLSX format, and we're going to save the name of the file as admin1 hydro power plant data. I'm going to turn off this button open output file after running because I don't want to see the Excel file in QGIS. I'm just going to run this here. So now when I run this, you'll see that I'll get a new Excel file created in the folder where I saved it. And here is the Excel file. I'm going to show you what that looks like here. So now imagine we started with some vector layers and we did some processing, we ran some expressions, and now we were able to generate an Excel file that looks like this. And you can see now we have each state or each admin1 unit in Sweden, along with all the names of all the hydropower plants and the total capacity in each state. And we can now fire off this Excel file to whoever needs it. And we are ready to do the next challenge. For the challenge, we're going to take this resulting layer and try to figure out something new. Well, let's learn about the next challenge that you can try. If you want to catch up to this point and work on the challenge, you can load this project from your solutions folder, power plants checkpoint 2. If you load the power plant checkpoint 2 project, you'll be able to catch up to this point where we have this hydro power plants classification layer, admin1 power plant capacity layer, which is the final layer we generated, and you can use this to do your next challenge. Veena, let's explain what's the next challenge.
Yeah. So for the challenge here, we want to add a new column, a power plant count with a total number of hydropower plants in each admin region. So here we are already doing the intersection in previous steps over the intersection. We used array sum to get the total capacity. Likewise, you have to figure out what is the function with array to count the number of elements in the list. So here you just have to do this, use the previous steps to get the intersection, and then find the appropriate function, say array, instead of sum, what you can use.
Yeah, so I want a new column saying how many hydropower plants are there in each admin1. So what expression would you use to compute that? See if you can figure out the right expression for that. Let's do challenge 2. We're going to learn about how to manipulate and create geometries using expressions. The QGIS expression engine has access to the features geometry. It has got many geometry functions, so you can create new geometries. You can take a geometry and edit them all using expressions, super powerful. We'll learn a way to kind of do this dynamically using expressions. There are many geometry functions, so things from simple things like doing buffer to doing intersections to more complicated things like interpolating points or splitting geometries. All of those functions are available in the expression engine, and you will be able to use that with the feature geometries to manipulate geometries there. There is a variable called @geometry, which you can use in your expressions, which refers to the geometry of the current feature. So if you have a polygon layer and you're trying to write an expression, each polygon will be geometry variable. So when the expression is being evaluated, it'll just say, I'm evaluating it for this feature, what's the geometry? And that will be stored in the @geometry variable. We're going to run a specific subset of functionality in QGIS called geometry generator symbol layers. These are really powerful ways to visualize the data with new geometries. So you have some data that is rendered on your map. You want to see the data in a different way. You can just write an expression and QGIS will show you with new geometries by running the expressions. It doesn't create new layers, it doesn't store new data, just on the fly computes the new geometry and shows them. Super powerful. It unlocks a whole range of use cases that allow you to visualize the data in a really powerful way. So if you have some data layers and you want to manipulate geometries and visualize them, geometry generators provide a really efficient way to do this with expressions. Let's dive back into the code and see how we can use this to solve a problem. We're going to start working on section 3. In QGIS, we're going to start and load a new project. So from your main data package, we have this project nearest neighbor. We're going to load that. This will load a new QGIS project with 3 data layers. At the base, we have the admin layer. This is the admin 2 layer for admin 2 polygons for a large state in India. We have each polygon for each admin 2 region. We have a layer of schools. So this is the data downloaded from OpenStreetMap of all the different colleges in this particular state. And then we have a layer of all the schools. So again, downloaded from OpenStreetMap, we have a layer points with all the schools. We're going to do a few analysis with this data set. One of the first things I want to do is I want to visualize for each school, which is the nearest college. So let's say I'm trying to figure out, do some analysis on the education capacity. I want to know, when people finish school, which is the nearest college they can go to. So I want to visualize for each school, where is the nearest college. So I want to connect each of these purple dots to the nearest college dot, right? So I want to connect this purple dot to whatever the nearest dot that exists for the college. And I want to visualize this. Now this can be done in multiple ways. There are some tools in the toolbox that allow you to do nearest neighbor analysis, but I want to visualize this so I can use expressions to create a new geometry. So I'm going to open up, select the schools layer, and in the layers panel, there's this paintbrush icon. If I click this, it's going to open up the layer styling panel. This is the way to adjust the symbology of the layer. I really like this because it's kind of interactive. So as soon as I change something, and it just changes and shows me the result. I don't have to go back and forth between the properties. So if you are working with any symbology, please use the layer styling panel. It is available. You select the layer and use the paintbrush icon to that. You can see here, this particular layer is styled with the simple marker symbology. That means for each of the features, it says, take each feature, render it using the simple marker. One of the lesser known facts that many of you may not have discovered is you can have multiple symbologies for the same data layers. So I can say I want the same point to be styled as a point with this color. I also want it to be styled in a different color. I can overlay multiple symbologies together. There is a plus button here which says add a symbol layer. Now if I click this, it's going to add another symbol layer, and it is showing this point. It is not duplicated the layer, it is just showing the same data rendered in 2 different ways, and they are all overlaid together. So I have the simple marker here, which is now in red color. What I want to do is I want to say, don't style it simply as a point. I want to style it as a line connecting to the nearest college. So I want to change the geometry of this rendered layer using an expression. There is a symbol layer type. Instead of simple marker, I can choose geometry generator. Geometry generator will allow you to write an expression which will change the geometry and will be rendered by QGIS as the resulting geometry. So I want to change the type to be a line string, and now I can say for each of this geometry, which is the currently it is geometry of this point, I want to create a new line which will be shown connecting to the nearest college. How can we do that? Let's open up the expression editor here. We're going to use this function called overlay nearest. This is a function that allows you to find the nearest feature from another layer. So let's write this function. We'll say overlay nearest. We're going to say I want the other layer that we want to look at is the colleges. I want to find the nearest college from another layer. We're going to say we want to find the geometry. So here, what do you want when you have the nearest feature? What do you want from that feature? You say I want the geometry of that feature. And by default, you can see limit is 1, so it's going to find the nearest feature, so the most nearest feature. We'll just make it explicit to say, give me just one feature. So now you can see the result of this is a geometry. So this says for every point, now I have found the nearest college. So we have the point. Now what we want to do is we want to create a line from the current geometry to this new geometry that we have found. So under the geometry section, you can see there are all of these geometry functions. The one that we want to use is called make line, which is going to say, give me 2 points and I'll construct a line from that, or a list of points and I'll create a line from all of those points. This is a list of points, which is from the college layer. I want to run this function and say make line from the current features geometry, which is add geometry, to this whatever we found, right? And again, we are now nesting functions. So you say make geometry from the current point to the nearest point in the college layer, and now we have a line. So you can see now we have constructed a new line using expressions. And when I click OK, you'll see magic. My points are now being connected dynamically to the nearest college from another layer. And again, all of these line geometries are created on the fly. So if I change some expression, it's going to change my output here. Geometry generator is really powerful. We have not created new layers. We've not created temporary layers. We're not taking any storage. All of this is being rendered on the fly. So super powerful, and you can use this for many kind of different visualizations. Okay, so we are able to create this nice visualization of connecting each school to the nearest college. And if you want to change something, we can go and update the expression. So I'm going to go and update the expression. Let's see the documentation for the overlay nearest function. You can see there are other parameters. There is a parameter called max distance. So let's say I want to find all the colleges, but I say the nearest college I want to find should be within 5 kilometers. So I will say my max distance has to be 5,000 meters. So now when I update the expression, you'll see that now the schools are connected to the nearest college, provided they are within 5,000 meters. Right? So now we have a different visualization. And this really allows you to kind of interactively explore the data set and kind of create new visualizations by changing your expressions. This was exploring the expressions for manipulating geometries. We learned about geometry generators. Sometimes you might say this layer might be useful as a separate data layer. What if I want to save these lines as a separate vector layer, which I can share and do some other analysis on? How do we do this? Well, that's the next challenge. If you want to attempt the challenge, you can go to the solutions folder and load the nearest neighbor checkpoint 1 project, which will catch you up to the current point where we have the geometry generator symbology, and we have this expression here, which will connect each school to the nearest college within 5 kilometers. Vigna, you can explain the challenge.
Yeah, so for the challenge here, so far we have created these lines in the symbology itself. Now we want to save this as a different layer. So we have the processing tool with geometry by expression. You can use this, you can use the same expression and create a new layer for schools with nearest college. And you will see a different layer where lines are created just like this.
Yeah, so if you ever wish to create a new layer with expression, this tool will come in handy. The geometry by expression tool exists in your toolbox, where you can write an expression. It'll look at the current layer, look at the overlay layer, and you'll be able to then take the resulting geometry and save that out as a new layer. So try this out, challenge 3. We have the last section remaining. This is on iteration. So far, when you've been working with expression, you get a feeling that it's like a programming language. You have if conditions, you can run functions, One of the key features of a programming language is to be able to do multiple things, like writing for loops. I want to run multiple expressions or try this 5 times in a single expression. QGIS expression also have a way to do iteration, and we'll learn some of the functions that allow you to do multiple expression evaluation within a single expression. Let's learn a little bit more about iteration. Again, we are now moving into the advanced territory. So if some of this seems a little advanced to you, that's okay. I want to share this with you that this exists. At some point, this might come in handy for you when you are working with expression and you say, I wish there was a way to iterate over my result. I want to share some of those expressions and share some of the use cases where it may come in handy. The iteration functions allow you to specify a list of things, and we already seen that many functions in the expression engine return a list. When you do overlay intersect or overlay, when we did the overlay intersect earlier, you saw that the result was a list. Now you have a list of things. Can I process each item of the list by running some other functions? So I can now run expressions within expressions. You can do this. You have multiple items in a list. You want to process each one. You can refer to each item using this variable element and then run functions that support this element variable. Here's one function called array for each. So you have a list of something. So here is, we are creating a list of 3 values, 1 to 3. This need not be an array that we create. It can be a result of an expression. So when we run some expression, we get an array, a list of values. And we want to say for each. So here is an array, and we say array for each, do this, element plus 1. So here the add element refers to each item of the list. And when the expression runs, it's going to run this element plus 1 on each item of the list. So in the first, it'll say element is the first element, which is 1. So this will become 1 plus 1. In the second time, it will become 2 plus 1. In the third iteration, it will become 3 plus 1. And you will get a result as 2, 3, and 4. So now within a single expression, you were able to take multiple values, run expression on each of them, and then get the results out. Super powerful. And there are multiple functions that support this kind of iteration. Let's see some of those functions, and we'll see how we can take our analysis that we've done so far with the nearest neighbor and do some additional processing on that. So we are starting the section 4 on iteration, where we'll learn the functions that support iterating over the results in an array. So far we have this schools and colleges. What we want to do is we want to now say we have connected each school to the nearest college. What if we want to say for each school, I want to get the list of all colleges within a certain distance. So let's say I'm doing some analysis and I want a list of all colleges in certain radius, and I want those list of items. We've already done something similar, so let's first do that and see how we can process those results using iteration. I'm going to open up the processing toolbox and use the field calculator. So I have a schools layer. I'm going to create a new field here called colleges. This will be again a text layer. What I want is a list of schools within 5 kilometers. So I'm going to use the overlay nearest function that we have used. We say, look at the colleges layer, and this time I don't want the geometry, I just want the names of the colleges. So I have the attribute called college names within the college layer. So give me the list of college names. I want it within 5 kilometers, so I'm going to specify the max distance as 5,000 meters. Now by default, the limit will be 1, right? So in the previous one, we just find the nearest college. I want all the colleges. I don't want any limit. If I say 10, it'll give me the 10 nearest colleges within the 5 kilometer distance. I don't want to put a limit. I say, give me as many colleges you find within the 5,000 meters limit. So I can specify -1. If you read the documentation, this is the way to specify the parameter where it said there's no limit. You specify how many ever colleges you get, right? So now when I do this, you'll see that my result would be college name, sorry. So you can see now I have a list of colleges returned by this expression. And if I look at this, each feature will have if I look at this, for each feature I can see the preview, it'll find the nearest colleges, and it'll give me the list of colleges that exist within the 5 kilometers. You can see the list, these are the list of colleges. Some of the colleges have the names not in a proper case. What if I want to just save the list, but I also want to convert the case into a proper case? So here is an example feature where all the names are in small case. This one is in a title case. What if I want to just take each of them and convert to title case? So now I have a list of things which I want to run some function on each of the case. There are many functions for string processing. There's a function called for converting case. So if I want to convert everything to an uppercase, I can run the function upper and say convert this to uppercase. Or I can run the function title, which is the title case. So what I want to do is I want to run the title case function on each of the items within a list. And when you find yourself thinking, I want to do something for every item in the list, you can reach out for the function that we just learned, array for each. So let's look at the documentation for this function, array for each. So we'll write the function here, array for each. Here's an array. So this function itself returns an array. So we'll say for each item in the array, I want to take the element and run some function. So I can just say I want to run the function title, which will convert this to a title case. And now when I complete this, you can see the results show that everything has been converted to a title case. So it ran on each item of the list and converted it to a title case. If I just say converted to an uppercase, you'll see that it's converted to an uppercase. So now I was able to run this expression on every item of the result that was created, that was returned by the first thing. Super powerful. You can kind of see how deep you can go and kind of build an expression that does something very, very complex. It's also very flexible, that allows you to kind of manipulate your results in an interesting way. We're going to keep it as a title, and we want to save this result as a list of colleges. So again, for compatibility, I'm just going to turn it into a string. So I'm going to convert this to array to string, which will give me a comma separated string from this. So I'm going to save this as the nearest colleges. Once we have configured it, we will now run this. Once we have configured this, we run this, and the results will be saved to a new layer where we have the information about the nearest colleges within 5-kilometer distance for each school. Right? And we were able to take the names, convert it to a nicely formatted title case for this. I'm going to show one more example of doing the iteration. This time I want to show you a function where we get a list of things and we want to select certain items or remove certain items from the list. So let's say we want to get a list of colleges within 5 kilometers of every school, but not all colleges. I only want science colleges. So what we want to do is take the list of colleges and select the ones which have got the keyword science in the title name. So let's see how we can do that. So I'm going to create a new layer where we say I want to only get a list of science colleges within 5 kilometers of every school. Here's a function that we have done before. So this one we have processed it and we get the names of all the colleges here. What we want to do is we want to say, look at this colleges and select all colleges which has the word science in them. So some of them have arts, and some of them are art colleges, some of them are science colleges, and so on. So I want to just apply a filter and say only select the science colleges from this list. We're going to use this function called array filter. Array filters allows you to take an array, write an expression only for the items where this expression turns true, those will be selected. So I'm going to run this function here. I'm going to say array filter, and the expression that we want to check is to say, does this name contain the word science? I'm going to use this function regex match, which will allow to specify a pattern and say for each element of the list, if there's a word science in them, only select those. And now you'll see if I just go through the list result will contain only the colleges which have the keyword science in them. Right? So we are able to now take a layer, find all the points within 5 kilometers, extract the names, convert it to uppercase, and filter it to only science colleges, all within a single expression. Let's just save this out. Again, we'll convert this to a string and save it out as the result. So I'm going to convert array to a string, and we'll save this out as layer called nearest science colleges. And now you can see in the output, the colleges have all the colleges within 5 kilometers, and the science colleges are only colleges which have the keyword science within them. Okay, we learned about iteration, two functions, array for each and array filter. We're going to do a final example where we will take the earlier problem that we solved of connecting each school to the nearest college, but we're going to update our logic a little bit. You can see many of the schools are connected to the nearest college, which are crossing the admin boundary. The white ones are the admin boundaries, so these are the districts. Maybe you want to say, I want to find the nearest college for each school that are within the same district. Do not cross the district boundary. And this may be restrictions for, say, scholarships or for any programs where you may want to send your students to this college within the same district. How do I find the nearest college for each school within the district? So here in my visualization, I want to connect each school to the nearest college, but they should not cross the boundary. So this one should not be connected to this one should be connected to this one. How do we update our expression? Okay. Now that we understand iteration, we can now update our geometry generated expression to make use of those and update and find those results. So we're going to do this step by step. So first we will say I want this was the expression to find the nearest college from another layer within the 5 kilometer distance. What I want to do is I want to now impose this restriction that find a college with this, has the same district as the school. And this may not be the nearest one. So I'm going to first remove the limit, say give me all schools. So I'll say limit -1. I don't first give me all schools, I'll apply a filter and find the school that matches. To be able to apply a filter, I need to be able to get the names or other attributes. So instead of geometry, I'm going to say, give me the features from the college features. So you'll get the full features, which is the geometry plus the attribute, and you have the list of those. So you can see now, instead of just names of colleges, you have the list of features which are within 5 kilometers, and as many of those that were found. We can now apply a filter. So we can say, I don't choose all of those. From this list, I want to apply a filter and choose only the ones where the district column is the same as the district of the current feature. And we can say there's a function called attribute, which will allow you to query for attribute from a feature. So we'll say from each element that was returned here, which will be the feature, check the district column. So this will tell you this is a college feature we found. This is the value of the district attribute for that feature. If that attribute is the same as the value of the district of the current feature. So this is the condition which will say this will be pull up the value from the school's district. This will pull up the value of the district from the college feature that was found. If they're equal, then only they should be selected in the filter. You can see now we have only selected certain features which are from the same district. And now we have the features. It's still a list of features, so I can just say give me the first one. So I have this one, give me just the first one. So I have a feature, and once I have the feature, I can extract its geometry. So there's a geometry function that says now we don't need the whole feature, we just need the geometry. So now we have the point geometry of the nearest college within the same district, and we were able to apply a filter and select those one. Now that we have geometry, let's just use this to make a line. So now we make a line that goes from the current point of the school to this nearest school. And now this is our final expression that when we update it, you'll see your visualization update. Now each school is connected to the nearest college within the same district. And you can see all of these lines, they do not cross the admin boundary. And this is something that is super complex, super hard to do, but now using the power of expressions, we were able to build an expression that not only allows us to visualize, but even you can use the geometry by expression tool to export this out. And this is a really useful kind of analysis that you can do just with one expression that would have taken you multiple analysis steps and maybe some manual ones to apply the filters. And we are ready to do the last challenge for the class. Here's the challenge 4. Vigna, you can explain.
So if you have your checkpoint open, you will see that there are many schools which has no connection with the colleges because we are just trying to connect it where district value is the same for both college and school. So here your challenge is to select all the schools which have no nearby colleges in the same district. So here we already have the expression to find schools and colleges in the same district. In that array, we want to check whether the length of that array is 0. So if that length of that array is 0, you will see that it is going to select all of it. You will use the select by expression tool here and use the expression like the same as above, but here you will have to, on the array filter, you will have to have one more filter to check the length.
Yes, the idea is when we do this analysis, can we find schools which have no nearby colleges in the same district? And maybe that's a kind of analysis that you want to do to improve the education infrastructure and build new colleges. I want to share a few last words before we go. When you're writing expressions, sometimes your expression can become very long and complicated. There's a way to comment your expression, so you can add some comments which will not be considered as expression, but just documentation. So if you write a line in your expression that starts with 2 dashes, that will be considered as a comment. So for example, if you are writing expression like length of add geometry greater than 100, and you want to add an explanation for you and for other users what this does, you can write a comment starting with 2 dashes. If you have a longer comment, you can also use this syntax /* and */. So if you want to write multi-line comment, you can use this syntax. Again, this will be not used by the expression engine, but this is useful to document your functions. And sometimes, as we saw, the functions can do a lot of things. So if you end up building a complicated expression with a lot of functions, do add comments in them that will make it readable and more understandable for the users. In the last slide of the presentation, you will see that we have linked to some additional resources. The QGIS expression documentation is excellent. I highly encourage all of you to go through that. It has documentation for all the functions and some of the other advanced syntax. You'll learn something new as well. We have a whole course module in our advanced QGIS course, which covers expression. We focus on the aggregate expression, which are again advanced expressions that you can use to do really interesting things. So if you want to learn, again, our courses are open access and have videos, so you can watch and learn more about this. We have a lot of blog posts which have explored the different applications of QGIS expressions, so you can read those. And if you like the geometry generator and you want to see something interesting and really unique examples, so there's a really nice GitHub repository which has got many interesting examples of how you can use geometry generators here.